Hello, my name is DarianM, and
I'm Alejandro.
and perfect. I did the code, and he did the
Art
and
the research.
okay, cool. Yeah, my phone's fine. Okay, basically, what this program does is really nice. Let me just run it. I'll show you. It's a game, very fun game, and it has all the perfect elements of a game. Mario, a shark, and a laser, right? So, as you can see, you got your Mario guy.
Wait a minute. Is that a shark with laser beams on the head?
Yes.
Okay, so we're gonna have to pay royalties to Dr. Evil.
Yes, that's what I was about to say.
Yes, we will. As you can see, I'm losing lives each time I hit the laser.
And so basically, it's an underwater level.
And once I reach to 0, and 0 should be right now when I hit me. Okay, game over. So, very simple, kind of nice.
Wow.
Yeah,
Pretty
so.
amazing.
It is kind of nice, isn't it?
So let me explain it.
How much?
Before, we had this crazy thing called asteroids, I think. I don't know what it was. Basically, they had some kind of ship, and they had asteroids flying all over the place. It was boring, you know, no sharks, no lasers, no Mario. A boring game. Horrible, horrible. So, what we did is, I took out all the useless code, basically everything, and I replaced it with the one good thing that they kept is thread game loop and buffered image. The back buffer.
Okay.
Now, the buffered image back buffer is what you see in here, the white stuff, when it runs.
Right.
This white stuff is what it allows all the images to move around. It's basically double buffering. So otherwise, you would see like every time I moved Mario, it would like be flashing and you would be really, really disorienting and you'd probably die. So it's always a lot better, no deaths. So just declare some variables, do some stuff. Randoms, XYs, live, score. Then we get into initialization. I'm running out of breath. No. Okay, so
take a pause there.
So, now I'm changing the tone. So, what we do here is that we're going to run the back cover. We already declared it right there. Boom. Now, what I use in this program is actually two images. One of a shark and one of a Mario. So, we declare those here. Well, not really declare. They're declared up here as buffered images as well. They're both buffered images, by the way. So this one is declared here. This gets the file mario.gif from the classes file in the source project. That makes sense, everybody. So, like, this project is called I Hate You Compiler because I really hate this compiler. So, basically, I put it in the classes file of that, and bam, the two files, it will find it. Now, if I move those files, you'll see e.print stack trace come up. And let me just show you an example of that. So I'll show you what kind of errors you can get. And the nice thing about that is that you don't need the files to make the whirlwind work. So let me just remove Mario for a minute. So, notice, the program will still run. And this is kind of amazing. You see, the program is still running, and the game, obviously there's no Mario, so you can't see much. But, notice here, where's the image? Basically the thing saying, I can't read the image, there's no image there. So let's put it back there, let's be nice to the compiler for a change. So, there we go.
The exclamation point, that could cause some problems.
No, it doesn't.
No, it doesn't.
Does not.
Surprising.
It would if it was the slash or question mark, but hey, and there he is, Mario's back, yay! Cool.
Hey.
Hey.
How do you get Derry? How do you get the
Yes?
Let's see.
Volume. That's sound effects?
No.
There you go.
I could have added sound.
Those are the thrusters of the
Yes, those are the shark's
That's the
thrusters.
sound of Gary's code crashing.
All right, listen, folks, listen. How do you get the laser beam to turn on?
That's a
and off
line.
like that?
And I'll get into that once I go into the update. Good. So, we're only on initialization. This is like one of the 5 core, what's it called, methods, yes.
Uh-huh.
So this is initialization. It does some other boring stuff that I'm sure you guys are not interested in. And then we got the good stuff, update. Now, the way that the old asteroids program worked is that they had a class called public void update. You're staring at right now. And this is where they did all the graphics. This in Paint, but they didn't use Paint as much as this. And the nice thing about this is that it allows you to do if statements and all that nice stuff. So you already noticed that I have something here. This y minus gives the artificial gravity for the Mario, not the shark. Shark does not have artificial gravity, only Mario. So that's good. And the plus makes this a solid floor at this point, 210. So then we get up here, this sets up simple rectangles like the floor, the back buffer, it draws it. Then over here you have 2 strings, it draws a score. plus itself each time. We'll get into this more later, and lives, which we start off with a set amount of 50. Now this updates every millisecond or so. It looks like from what I've timed it at. Well, not really millisecond, like every centisecond, I guess would be a word. Because what I do here, if I scroll down a little bit, I'm getting ahead. Just ignore this, ignore this, ignore this. I would explain it all in a minute.
You may want to use the markers, Darian, because remember, we're recording this.
Yes, I know.
And if you point with your finger, the person looking at this is not going to know what line you're referring to.
Good. Okay, so I got a marker now. So, boop. Boop. Okay.
Okay.
That is basically telling me not only is it acting as a counter for the time and how much time you're playing, but each second or centisecond or however often it updates, really, it updates your score +1.
Right.
So that's what you saw rapidly going on and off. So, and that happens as long as your lives are greater than 0.
Darian. Marker.
Okay.
No.
Okay, no more marker. So, I'll point with the mouse, I think. So, then if there is no more lives, game over screen. This is what this is doing. It gives you your final score, stops moving up the score, gives us some credits, and an enter to replay button. We'll get into that more later. That's more of the stitch case statements.
So all of this is in
The update.
in the update, okay.
Now, you may be asking, well, how did I check the lives? How did I make the objects interact? Key question, I didn't. What I did instead is I have the coordinates interact, which is really interesting. So, basically, this part is actually the shark's movement. This is its movement algorithm. It generates a random coordinate, x rand, y rand, and it moves towards that coordinate. Now, for the interaction, by the way, up here I already explained that, sorry. For the interaction of the objects, I believe it is this line right here, I should have explained it, sorry, I got ahead of myself. This line is what is causing the laser. Like I said earlier, the score doubles as a counter. Every 20 centiseconds, or however often this updates, I'm just going on centiseconds, it draws the red line from the specified point, which is roughly about on top of the shark's head. I think it's a battery-looking thing.
Yeah.
So, and each time you lose a life, or rather hit the object, this is what I was talking about earlier, the object interaction. How I did it is, if the x value of the Mario is greater than or equal to the x value of the shark, basically saying if you saw how the laser was always firing to the right side?
Yeah.
Right side, yeah. It's always firing to the right side. So basically, if it's greater than, so it's on the shark or it's on the laser, it fires. And it has to either be less than the y value of the sharks, like the shark is about 30 pixels, right? So, or 50 rather. So it's either less than 10 of the shark or greater than 10. So that gives us a range of death. A death range for the laser and the shark combined. You hit that death range, you're losing some lives. And they lose lives fast because each
the farther away you are from the laser, the less likely you are to die.
Exactly. Not exactly though. Because
Well, I was going to say that I have never seen that before in a game. I mean, you were able to come up with that, guys. That's very ingenious.
yes, what's it called? Let me run it again because the shark's movement paths I did say were random. So the goal is to stay as far away from the shark as possible. But you'll notice that sometimes the shark jumps, as you see, right? It changes direction. It's just doing some. Yeah, you see it jumps. You see it jumping.
Yeah.
That is because whenever it hits the bounds, which are here and here, I had a little bug in the program where whenever it would fly off into the negative coordinates, because this is 0, 0, whenever it fly off into the negative coordinates, the shark would disappear and never come back. So that was bad. So I kind of made it bounce off those, basically, and bam, he hit himself. So,
Can the shark... Are you planning on implementing mirrors so that the shark can hit itself?
huh?
Mirrors so that the shark can hit itself.
The shark doesn't take damage.
Is there a way to win?
Yeah, your score. It's a high score game. You want the
there
high
is.
score
There's
possible.
no way to win.
Okay, wait. Next question. Philippe.
Now, I see that when it's making it bounce off every time it gets every time it gets a certain distance to the border, it kind of just respawns back at a set point and teleports around. Are you going to implement physics that make it literally bounce off, or are you going to make it loop?
This is actually a random thing. Now, the problem with many random generators is that they use an algorithm, and as you may know, algorithms tend to repeat. Now, however random they may seem to be, they're repeating, and you see this here. That's that repeating action in action. So, and you can't really fix that with the current implementation.
No,
However, if I were to enable a more complex physics engine, I would do that. But mind you, I'm no physics expert. Okay, I'm in
well,
chem.
there's already
I'm-
physics engines out there, such as Box TV.
I could have. I didn't. You know, it's something that's a learning experience. But it works perfectly fine. I like it. I like the shark. It looks nice.
Yeah. No, it's a very interesting game. I mean, it's,
Yeah.
It's quite.
Now let's jump on because I'm running out of time here.
Explain to us why is it that every time we're dealing with applets, you've got this paint graphics G.
Yes.
And then explain to us how you incorporated that in your code.
Basically, G is the most common. Graphics is an object in the paint method, commonly used in methods. What it allows you to do is everything we did up before, G2D, except G2D is a variant of it, rather. And I'm only using paint here for the back buffer. But in my other programs, if you've noticed,
Right.
I use paint as the main class instead of update. And this allows me to draw the image, and all I have to do is call paint, or rather repaint if it's multiple of them,
Right.
and it will actually run that method. So it's really great. Now we'll get into threading, because this does use threading. So, you may be asking yourself, but I've tried this before, I can't seem to draw the image and move at the same time, as fluidly as I did. Well, you're not using threads. Threads allow two separate things to run simultaneously. Most commonly, a key listener, an action listener, and the drawing part. As you can see, I can press spacebar, I can press sideways, and there's little to no delay, because they're running simultaneously, or rather, as close to simultaneous as you can get. Here's an example of repaint, by the way. So, okay, now I declared the thread up there. It was called game loop, so I'm just initializing it, doing some stuff. I'm starting it in the start method. That's the point of the start method, to start the thread. Kind of self-explanatory there. And I guess you can guess from the name of the run thread what it does. Anyone? Here's a hint. It runs the thread. There you go. Billy got it. Okay, cool.
Of course, Billy got it.
And it doesn't be all wild. And that's basically it. You can just copy paste that, make it work. It's nice. Stops the thread. Game update. I don't know what it does. And that's a very weird thing for me because I usually know every single thing in my program. I just left it there. It looked nice. So it says does nothing, updates nothing. It seemed that the template I was using,
It's
aka
just another
asteroids.
just another void.
Yeah,
actually.
aka the asteroids program, wouldn't let me delete it. So I left it there. It looks nice.
But in other words, if you were to comment that out,
It would
would
not like it.
it wouldn't work properly.
Yeah, it doesn't
Well,
work.
delete it now.
Okay, so
At least
let's take a look at the code. Let's see if we can try to figure it out.
I don't know what it does. I haven't played around with it. I just
Does
ignored
nothing.
it. It does nothing, basically.
Delete it.
But look, I'll show you. When I commented it out, I got a weird error, I believe. Let's see if it does it here.
Maybe it's
Yeah, you see? It's missing it. It
Well,
wants it. It
Let's see
cannot
what the
find.
error is.
It can't find the symbol method.
Oh, okay. Maybe.
Basically, whatever this template is, it really likes game update for some crazy
No,
way.
I think that
maybe it's like its wife or something.
it's
I don't know.
maybe at one point in like the base of the program, it calls upon that method,
Yeah.
Well,
Yeah,
yeah.
and then maybe.
But what does that method do?
Nothing.
It's probably set up to update the game, is what I can get. It's
Well-
like in a more efficient way than simply.
It sounds to me like there was some code in that method,
That I
and when Darian went
Go.
ahead
I
and
went crazy on it.
started doing code on his own.
It became irrelevant.
Well, what happened was
No.
the program overall
thing
is
is
looking
that-
for the method,
Mhm.
but since he deleted
Well,
the code for it,
Yeah.
it doesn't have it, but it's still looking for it.
Yeah, it's
And since it's
requesting
void,
that it
since it's
requires the method.
Right. But since it's
Darian,
void,
You can.
and it doesn't return anything, it's not making it crash. But it needs to be there. The signature of the method needs to be there anyway.
Mhm. So I didn't explain
You
this.
can do
for
system that at the
threads.
print line to see when it's called.
I could have, I would have, I
The
should
thing
have,
is,
I
it's
was
not
bored.
console, so I don't know how you're gonna do that.
Okay. So I forgot I mentioned this. Thread. Threading requires the runnable implement, and these are just GUIs, like interfaces that you can play with. And the keyless